recursion case for annuities. When we are talking about the recursions, it means that we can see a pattern in finding the value of the annuities. So let's look at the simple annuities where we have $1 every year. We are looking at the life annuities, okay? So $1, $1 every year, and then here we can say that the APV of these annuities equals to 1 plus VPX plus V square 2px plus V cube 3px plus and so on. I can rewrite this as 1 plus VPX times with 1 plus V px plus 1, because 2px here, if we factor out VPX, be left over with V, and then 2px here is px times with px plus 1. So you're going to have this, plus here would be V square 2 px plus 1 plus and so on. So here is 1 plus VPX times with 1 plus VPX plus 1 plus V square 2px plus 1. Here is a double dot x plus 1. If I repeat the same pattern here, I will have 1 plus VPX a double dot x plus 1 here, rewrite it as 1 plus V px plus 1 plus V square 2px plus 1 plus and so on. It is equal to 1 plus VPX times with 1 plus VPX plus 1. I factor out VPX plus 1, then I will get 1 plus VPX plus 2 plus and so on. So this one I can rewrite it as 1 plus VPX times with 1 plus VPX plus 1, 1 plus VPX plus 2 and so on, which is VPX plus 1 times with a double dot x plus 2. So here you can say that a double dot x is equals to 1 plus VPX a double dot x plus 1, and a double dot x plus 1 is equals to 1 plus VPX plus 1 a double dot x plus 2. You can see the patterns is recurring, so we call this the recursions for the life annuities. If it is in the case of term insurance, you are going to get a double dot xn equals to 1 plus VPX a double dot x plus 1 and minus 1. Here is n minus 1 because you already deducting one term. In the case of monthly payment, a double dot x m, you are going to get, it's still the same thing, it's just that now it is instead of x plus 1, you are going to have x plus 1 over m. So for here you are going to have 1 over m plus v to the power of 1 over m 1 over m px times with a double dot x plus 1 over m. That's it for the recursion. Thank you.